final part of this section 2.4, using what we know about continuous and continuity to find the value of A. Find the value of A, all right, and that's what it's saying right there. So the function is continuous. So here we have a function, and it's a piecewise function, and it says it's continuous. We need to solve for this value A. Now the key thing is when, like we stated before, if the function is continuous, and this is a parabola, and this is a line, both continuous functions, the only place that you could have discontinuity for a piecewise graph would be at this value, this possible break. So right here, this is the possible break. Okay, this is the possible break. This is where you would have possibly a possible break, which means a jump. All right, and that always occurs with a piecewise graph. So when you have that, we know that it is continuous. So that means that there is no break. Okay, so there is no break. So because there is no break, all right, we know that, all right, because it's continuous and there is no break, all right, and that's right, all right, no break in graph, that would mean that at this 3, for both these functions, they would have the same value. All right, so that means the limit as x approaches 3 to the right of this function f of x has to equal the limit as x approaches 3 of the left of f of x, and that has to equal f of 3 if it's continuous. That's what we know. So using that knowledge and that, all right, understanding, we can simply solve this by taking this 3 and plugging in for x and solve for a. So we know that the right side, which would be every all values greater than 3, we can write this out saying 2a times 3, so solving this limit, has to equal this limit right here, which would mean that we're plugging 3 squared minus 1 in there. These have to be equal because this is the right side, all right? That's the right side, and that's the left side. That's how we solve them, and it's continuous. So now we solve this, and now it's just an algebra problem. 2 times 3 is 6a. That's going to be 9 minus 1, which is 8. A is going to equal 8/6, which we can take out of 2, so it'd be 4/3. That's it. A equals 4/3, and that's what makes it continuous. Moving on, we can try the same kind of thing as it's continuous. So once again, if we know this is true, we know that the limit, all right, because it's a piecewise graph, and this has to be a continuous function, the limit as x approaches 1, this is the possible break, but since it's continuous, we're going to use this value right here, and that's what we're going to use for C. So that's the value we're going to use for you. Use this for C, okay? So that's why we're going to go to the right side of this function f, and we're going to compare that to the limit as x approaches the left side of this function, all right, f, and we know that has to equal f of 1 because it is continuous. So to the right side of f, that means we're going to pick up values greater than, so we're going to take arctan, and we're going to plug in 1 in there, all right, 1 minus 1, and then we take, that has to equal the left side, so left side is going to be everything greater. We have a, and it's going to be e 1 minus 1 plus 3, all right, and let's solve this a value. Arctangent of 0, okay, and we have a e to the 0 power, which is 1 plus 3. So arctangent of 0, well, arctangent is going to be in these first quadrants. When is arctangent 0? Well, 0 means that tangent, all right, we're looking for the angle that gives us a ratio of 0. Well, where is that equaling 0? Well, it's going to be right here because remember, tangent is sine of theta over cosine of theta equaling 0. And right here we have 1, 0, and that is going to be right there. So this arctangent, what angle do we need? That angle is going to be 0, okay? 0 is our angle that we're looking for, and therefore, that's what we have there. So arctangent is the inverse of that. That means we're looking for an angle. That's our ratio. Just a little quick review. All right, that's our ratio. Looking for the angle. Look for the angle. And so we know that value is 0. Okay? We're talking about this right here in our coordinate axis. This helps figure out that. All right, so that's 0. We know that this side right here, E to the 0 power is 1, so we have a plus 3. And so what does a be? Well, it's going to equal negative 3. A has to equal negative 3, and that, my friends, is going to give us our value for a that will allow us to have a continuous function. A equals negative 3. All right. Well, let's try one more. All right. Find the value of a. Find the value of a. All right. So that's continuous. So once again, where's the possible discontinuity? Right here. That's the possible break. So we know that the limit, because it is continuous, the limit as x approaches 4 to the right of this piecewise function for f has to equal the limit as x approaches 4 to the left of this piecewise graph, and that's going to equal f of 4. All right, that has to equal f of 4 because it's continuous. So that means when I plug in 4 into here, okay, into here, all right, so the right side would be every value greater than. So the right side would take the limit of 4 minus 3. And that has to equal, when I plug 4 in the upper portion, which is going to be 2 times e a 2 minus 1 minus 2. Okay, now we're going to do some algebra. Figure this out. So now we're solving for a. So now we're going to solve for a. Okay, to do that, 4 minus 1 is, that's not a limit. That's supposed to be a natural log. I'm sorry, wrote that wrong. So hopefully you caught that. All right, that's a natural log. That's where I get that, sorry. So we have the natural log of 1, which we know is 0. This can't really simplify. You can't, this is 2a minus 1, so I'll just write it as 2, all right, e to the 2a minus 1 minus 2. So basically that's the same right there. Oops. That's frustration right there, my friends. That's the sound of frustration. All right, 2a minus 1 minus 2. All right, now we're going to finish up our algebra. We're going to add 2 to the other side. That equals 2 e to the 2a minus 1. We're going to divide by 2, so we have 1 equals e to the 2a minus 1. This is a good algebra review. How do you solve for an exponent? We have to use the inverse operation. All right, use the inverse. Use the inverse. Solve for this. What's the inverse exponential? That's a log. Allow you to log it. So we're going to natural log 1. All right, natural log. That's what we did in our previous videos. When we do that, what happens is that we use the inverse operation, which means that that's canceled out. The natural log of 1 is 0. All right, and as long as we natural log, we can do that because that's algebra. We have 2a minus 1. Add 1 to a equals 1/2. Bada bing, bada boom, a equals 1/2, and that's how you solve it. All right, going through here. All right, well that's it. This is homework that you can get started on. It's a lot of problems. All right, I'm going through, but it'll end up being not too bad. All right, let me do it. So if you have any questions, make sure you email me, talk to me, but hopefully this helps you out. Good luck and God bless on your problems, and hopefully this lecture helps.